Maintenance track manual for Superliner passenger cars, Pullman Standard Division, Pullman and Corporate Charles, Chicago, Illinois 60628. We're making the trains worth traveling again. Section 3 Electrical Power System. Primary battery power. The primary power of all bi-level types of the cars are 480 volt, 3-phase, 600 Hz power supplied by the alternators of the locomotive. A maximum of 800 kilowatts at the 80% of the power factor can be drawn in locomotive auxiliary power until the power unit, and for a 7-car train it consists. The voltage drops caused by resistance of the powertrain lines extreme consists of the 7-car does not exceed 17 volts phase to phase under maximum load equal distribution load among the cars. Maximum load will occur, for example, in the starting of the cold or the ambient temperatures of negative 30 degrees of all lights on the electric. All lights on and etc. The car is equipped with a 64-volt storage battery. The volt battery is used. The primary power is interrupted. The head-end power jumpers. The electrical power in the bi-level cars are supplied by the alternators on the Amtrak locomotive through the inter-car jumper of the 480-volt VAC power trains line of each car. These also 60-volt nominal storage battery on each of the car. 480 vac train line. That 480 volt 3-phase power is transmission from car to car through the four 3-phase jumper cables at each side. At both ends of the car, there is permanently attached 3-phase power jumper cables and power receptacle. A power jumper cable plugs into the mating receptacle adjoining the car at the rear end of the car. It consists of the power jumping is looped back and then plugged in the adjacent power receptacle. The power receptacles are color-coded red. Power jumper. Each power jumper consists of 3 power conductors and 3 smaller control wires. The power jumper has the power pins and the 3 shorter counter pins. With any power, the jumper is disconnected. The shorter control pin breaks the contact first. This opens the contact with 480 volt supply. The locomotive prevents the power points of the disconnecting underload of the remaining hot when disconnected. 27 of the pin connectors, the inter-car communications control loop of the condenser train through the 127 point jumper at each end of the car. There are 227 points of the control receptacles at each end of the car. One in the center line of the car below the end of the door of the train line car to the car. The other 27 point receptacles located adjacent to the power receptacle at the corner of the car is used in train line car to locomotive. These 27 point receptacles are color coded blue. Dummy receptacles. In addition, with the dummy 27-point receptacle located adjacent to the car receptacles below each end of the door, the dummy receptacle has only one active pin number, TB2 and 20A. When a jumper is connected with the 27 point of the car to the acceptable at the rear of the last car, the adjacent dummy receptacle of the car is completed to energize the loop relay. Major system voltages: 480 VAC 3-phase. 480 VAC power enters the individual car by conducting, which conducts as an undercar 48 vac junction box of the electrical blocker. The cables are connected to the main power of the breaker on the car. The CB for number 41 located on the circuit breaker panel and the electrical locker. The line set of the brake feeds of the 2 rows of the breaker are different with the 480 vac system. The 120 vac of the 28 vac system, the 3-phase, the 9 kVAs, and the 120 vac and the 3 kVAs at the 28 vac transformers are located in the electrical locker of each of the car. The transformer supplies reduce reduced voltage of the control circuit of the lighting system. The 28 VACs intended to use the passengers, such as all passengers controlled by the reading lamps and attendant call buttons. The 480 over the 120 back of the transformer in a single 3-phase 2-winding Y connected transformer having sufficient capacity to supply is required 120 services on the car. The 420 and 28 428 over the 28 VAC transformer, a single three-phase winding Y-connected dire tape of the transformer having sufficient capacity to supply required 28 VAC services on the car. 72 VDC and 64 VDC storage battery. The comply the auxiliary power supply is located in the equipment room connected. It consists of the 50-cell battery and a battery charged lower voltage power supply. The 50-cell battery is made up of a 5-cell block battery, which is delivering in 32 amperes of the minimum 2 hours at 0 degrees Fahrenheit electrolyte temperature down to 1.04 VPC voltage per cell. The battery charge of the low voltage power supply is housed in the same enclosure. The battery charge of the section of the BC LVPS the LVPC, the voltage pressure, the battery charging connection with the LVPCS is a three-phase control of the rectifier to recharge offline during the normal operation, switching the flow to the high rate of the recharging automatically with the charge operation. The current limit of 16 seconds after the battery reaches the high rate of voltage level, depending on the temperature, and an additional 2.25 hours of the consistent current charging of 3A, the charger returns to the float charging. The low volt power supplies unregulated supply consists of three-phase transformers, 6 diode bridges, indicators, and capacitors provided in a filter output of the loading during the normal operation. The BCL under the LVPS is provided to the control of the load shed relay and the power switching devices. The load shed relay is an external device located in the auxiliary relay panel in the electrical locker, which disconnects all but emergency loads connected to the BC LVPS voltage voltage falls to 52 volts. The power switch device is in contact with the BC LVPS with the transfer load of the LVPC battery. Output LVPC falls to the 62 volts. 208, the back line of the 30 at 120 back line lines of the neutral. The dining cars have additional transformers, which supplies the 208 volts of the three-phase A and C. Three volt phase A. C and 120 volt single phase AC to operate the food service applications or appliances. Also, the dining cars are equipped with the acceptable 220 phase 60 Hz wayside power. Another transformer in the car stands by power circuit to reduce the 220 volt wayside power to 208 volts AC to operate the food preservation equipment. This dining car and the only cars equipped to accept the wayside power. The dining car is 75 kVA's food service transformer consists of 3 single phase of the transformers wired to the delta primary, Y secondary, and transformer operates the form of 480 volt 3-phase 60 Hz supply furnishes 208 back line to the line 3-phase 120 back line to the neutral single-phase 4-wire power system and food services equipment. All voltages of various Amtrak bi-level cars ungrounded. The frames of all silently mounted electrical apparatuses on the 120 back of the grader are grounded to the car body. The safety ground is on this line of the KB12 of the local voltage power supply outbreak of the wire. The TB is connected to the car body frame of the electrical locker, making 72 volts of DC system at a 2-wire ground system. All load circuits are controlled by power protected by the circuit breaker. Except as noted, all breakers in the electrical locker are in the electrical locker. The operating voltages of major system and equipment of 480 vac of the 3-phase are the air conditioner, compressor, the condenser units, the air conditioner, evaporator, blower motors, the B&N equipment from the room heater, the floor and overhead heater, the hot water heater, elements of water is treatment system, low voltage power system, battery charge system, 9 kVA, 120 VAC vac transformer, 3 kVA, 28 vac transformers, the dumb waiter assist station, the attendant station, provisions only, food service transformer, 25 kVAs at 280 VAC transformers. The 280 VACs at 120 VACs, the dining car only 220 VACs over 208 VACs, wide side transformer, refrigeration units, freezer units, utility room, ambient controls, microwave and conventional ovens, dishwasher, toast for coffee maker, dish warmer, hot food container, counter, hot food warmer, grill. 120 VACs at that 120 back at 3-phase. Fluorescent light in the ceiling in the cove. The AC fixtures, stairway, air, toilet, body lights, vestibule connection signs, etc. Convincing outlets, AC receptacles, indoor thresholds, heater, exhaust fans, controls the havoc in the hot water systems, water cooler, materia area, refrigerator, soup and coffee warmers. The 28 VAC 3-phase signs. No smoking cafe, directional passenger reading and incident lines, attendant call system, ASL lights, the 70 VDCs, the communication system, the braking indication marker lights, stray lights, emergency lights, DC level ASL lights, the system which loaded the shed, the door control, door operating system, wheel slide, upper level cove lights, lower level cove lights, woman lawns, ceiling equipment, room ceiling lights, equipment, electrical locker until and utility room lights, onboard surveillance system provisions only. 311 switch and brake panels, general arrangement. The main circuit of the breaker switch panel is located in the electrical locker for the accessible reducing wiring. The main circuit breaker switch panel consists of the power supply breaker section, the lighting and the control breaker section, and the selector of the lighting and control with the switch panel. The 480 volt breakers are located in such a manner that to minimize the possible accidental misuse. The circuit breaker is mounted in the panel made by laminated Fenlock. The main circuit breaker there is arranged and so it is easy to accessible. Any conditions assigned to the dead front of the prevent the operator from coming into contact with live parts of the operating switches and the circuit breakers. All switch breakers are provided with a name clearly identifying the circuit which one end controls. All breakers indicate one of the toggle up and toggle off with the toggle down. The base panel is designed in all types of cars, modified by the adding, subtracting breaker and switches to the wayside power. The circuit breaker of the dining cars are located in the B end of the equipment room near the wayside of the power transformer. Here is a picture of a this is an electrical locket circuit breaker. You have your 480 volt VACs, the 28 VACs, and the switch panel, and the 120 VAC with the 70 VCs. Alright, I screwed up a second here. The battery disconnects the breaker located at the battery charger. Low voltage power supply enclosure of the B end of the equipment. The sign is placed on the electrical locker circuit breaker, indicating the power disconnect and breaker location. The food service equipment, food preservation equipment service breaker of the dining cars located in the food service equipment power distribution panel. This panel is located near the B end of the utility room bulkhead wall. The 480 volt breaker. The breaker is a 480 volt. The toggle action of the indicating the type of the approved equivalent breaker is type of the higher shock resistant design of the suitable railway service and interrupting rating as the least of 1400 amperes of the RMS 480 volt AC. The 28, 120, and 208 over the 128 volt breaker switches. The switches for the 28 and the 128 volt. The 28 and the 120 volt are toggle action at the approved equivalent. The 28, 128, and 208 of the 120 volt breakers are improved by the type of high shocking resistant design suitable railway service interrupting rail rating at the least. 10,000 amperes of the RMS at the 28 back for the 28 volt breakers. The 10,000 amperes of the RMS at 120 back at the 120 volt breakers. The 10,000 amps at the 10,000 amps of the RMS at 120 volt over the 240 volt back and the 208 over the 120 volt breakers. The 74 and the 600 volt breakers. All 72, 64 volt DC breakers are required overloading protection provided by the circuit breaker switches, magnetic thermal type strips, and shall clearly be shown on and off. The breakers are approved with the type of the high shock resistant design suitable for a rail service interrupting rating at least of 5,000 amperes at 120 VDCs. Power supply breaker location, physical description. The power supply breaker of the panel consists of 480 volt breakers. The power supply for the breaker at the point heart of the main control breaker panel is located in electrical locker. And lighting controls panel lighting and control breaker panel. It consists of a 28 volt, 120 volt, and 72 volt breakers. The light controlling the breaker is part of the main circuit breaker paneling located in electrical locker. A selector lighting in the control switch panel is the main part of the main control panel located in the electrical locker. The main part of the circuit breaker selector switch panel is arranged with the lighting switches. The lighting circuit breakers are equipped together except for the special area switches such as counter lights in the kitchen and mature areas. The battery breaker panel. The battery breaker is located in the battery charge low voltage power supply enclosure in the B end of the equipment room. Dining car distribution and the center consists of one panel. The panel consists of the following circuit breakers provided in the car builder by the car builder: 28 4-vac breakers, the miscellaneous food service equipment 2, the food preservation equipment 1, individual equipment 21. Wayside power panel. The wayside power panel contains the automatically transfer apparatus accessories with actuated either in the two-standard by the plug transfers and the operation of the food preservation equipment of the dining car for the normal head age and power of the standby. The wayside power is located on the B end of the equipment near the wayside power transform. The panel consists of 20 vac transfer power circuit breakers located on the dining car. The convenience outlets are distributed on 3 phases of the power supply within 3 ground fault interruption receptacles per car. The 3 circuits of the sleeping car will cover the convenience outlet and 1 of the ground fault interruption receptacle part per car. 1 circuit for each of the coach sleeping cars, which will cover the convenience outlets of the toilet passenger areas only. The 3-2 the coach electrical power system. The electrical power system coach consists of 3 parts of the following distribution of 480 volts, 3 volts, 600 megahertz primary train line power, distribution of reduced AC power, distribution of DC power. Each of these parts are discussed separately. 321 distribution primary power. The primary power of the voltage of 480 volts is used directly in the coach figure of the following equipment: the air conditioner, compressor, the condenser motors, the evaporator blower motors, the hot water tanker heaters, the floor and overheated floor and overhead heat, and the waste treatment system, the battery charge and low voltage 72 volt DC power supply. The 480 volt 3-phase 600 Hz power train line are connected by the 3-phase of the 150A main power circuit breaker, which turn and connected by the 3-phase 110, 15A, and 30A and 40A individual circuit breakers associated with the equipment transformers receiving the primary directly. The circuit breakers are located in the breaker panel located in the electrical locker. 3-2 distribution of reduced AC power. The 480 volt AC primary power is reduced to separate the transformers of 120 volt 3-phase 600 Hz, 28 volt 3-phase and 600 Hz levels of respectively 120 volts AC outputs of 480 volts to 120 volts of a transformer as used in the following equipment: draining heaters, exhaust fans, water coolers, ending door, thresh heaters, vestibules, passageways, stairways, covered loads, upper level, lower cover lights, toilet, woman lounges, mirror lights, acceptable AC receptacles. However, the hot water heater control, fresh air damper, and the HVAC controls, shunt trip fuses, no voltage relays, NVRs. Back out of this, here is a coach power distribution diagram. It's very small. You can find this at RR Fallen Railroads SL-OM Supercharged Maintenance Liner. See if I can't zoom in here. I wish I had a little. It's very low. I can't read it, but. 28 volts output of the 480 volts and 28 transfer from the following equipment: the car signs, attendant call system, upper level reading lights, upper level, lower level ASIL lights. Number one, individual outputs of 480 volts to 28 volts. Transformer includes the 68A fuses to facilitate the reducing of wire system size of the circuit breaker panel. All 120 volt and 28 volt AC inputs of the individual equipments are protected by the individual circuit breakers. The circuit breakers are located in the circuit breaker panel of the electrical locker. 323, the generation distribution of the DC power. The direct power nominal of 72 volts is developed an auxiliary power system. The system consists of the following: 50 cell nickel cadmium storage battery, a battery charger, low voltage power supply, the battery temperature sensor, and load shed relay. The auxiliary power system produces a nominal 72 volt due output. The output is passed through the 60 amp fuse to the LVPS, the B end of the equipment room, and the 40 AC and a 40A circuit breaker is distributed in individual equipment through the separate circuit breakers. These equipments are the brake indication marking lights, the communication system stair lights, and the emergency lights of the VA non-voltage relay. Upper level ASILs and number two upper and lower level cove lights. Number two, wheel slide brake control, intervestibule end control, women's lounge, closet, equipment rooms, lockers, utility storage compartment lights. On board surveillance systems optional. As shown in Figure 3.2, the negative down due the line of the battery charge is connected with the train line. The communication of the control train line in which the negative battery line each car of the train is connected. The negative battery is grounded in the car body of the circuit breaker panel of the electrical locker. Loop of the control circuit that is used in the train line. Negative line is establishing battery source. The circuit continuing the train line brake application of the release of lights. Loop circuit is completed by the jump ring of the communication control training receptacle dummy receptacles together at the end of the training farthest from the locomotive. The low voltage power supply contains a power switching device which transfers the load from the low voltage power supply. The battery output of the low voltage power supply falls between 62 volts is loaded shed relay. The LSR, the load sheet shed relay, is controlled by the battery level sensing serving circuits. Battery charged and energized by the battery level falls to the 42 volts, and when energized, the LSR, the load shed relay, disconnects all but the following emergency loads: brake indication marker lights, communication system stair lights, emergency upper level and lower level lights. Number two, the 50 cell battery is formed by the 10 NIFE M405-5 block batteries. The batteries deliver a 32A, the minimum 2 hours of the 0 degrees Fahrenheit electrical temperature down to 1.04 volts DC. A battery is located in the right side of the bay end of the equipment compartment. Is at the accessible outside of the car. Removable access of the doors can be readily removed through these doors. The battery charge and low voltage power supply, the BC LVPS, as the housed in the floor mounted with the enclosure of the B end of the equipment compartment. The enclosure is 20 inches high, 32 by 9/16 of an inch long, and 12 by 1.5 inches deep. The enclosure is finished with one white epoxy textured paint that provides a durable exterior surface finish and aids maintenance in dimly lighted areas. Access through the removable top of the front panel's captivity hardware is used on the front of the cover. A reset switch and the failure to indicate the indicator charge output of the current meter of the LVPS, and on the indicator mounted on the front panel of the Figure 3.3. Here you see a battery charged low voltage power supply front panel. The battery is in the circuit breaker and inside the battery charging of the voltage power supply and the charger of the output current. The output battery charger is the battery is protected by a 50 amp circuit breakers located in the battery charge enclosure. The battery charge portion of the BC LVPS and the three-phase full wave bridge rectifier, which is adjustable float high rate of the current limit points of the float high rate and the voltage compensated with the temperature variation of the battery compartment of -18 to 55 degrees and 55 degrees Celsius. The battery charge of the red charge of the battery off of the line during the normal operation, switching the float high rate of the charging on automatically when the charging operation. Current limit is 16 seconds, and the battery reaches high rate of the voltage dependent on the temperature. After additional 2.25 hours, the constant changing of the 33A charge return to the floating charge. The load voltage power supply is an unregulated supply consists of 3-phase transformers, 6 diode bridges, indicators, capacitors, and provides a filtered output of the loading during normal operation. The BC LVPS is also providing the control of the load shed relay, the power switching devices, temperature compensation, recharging time, excessive charge, recharge time, failure indicator, and load shed relay. The external devices are disconnected, but emergency loads connected by the BC LVPS battery voltage falls to 52 volts. The power switching device is contacted with the BC LVS, which will transfer the load of the LVPS. The battery, which output the LVPS, falls to 62 volts, but flow to the high voltage temperature compensation circuits are all fail safe. This is if an open circuit occurs between the BC and LVPS and the temperature censoring of the battery compartment output of the voltage battery charge in the minimum. There's two solid states, and the timers are used to control the high rate of the recharge to reduce the output of the current battery charge of 5 amperes and charge that operates and the current limited for more than 9 hours. At the same time, the front panel and the remote indicators are alerted by the pressing the reset press button and return to the recharge to normal operation. The malfunction has been corrected. The battery charge, a low voltage battery supply. The control specifications are as follows. The battery is a Type 4 M405-5, 10 blocks. The capacity is 129 AH. Battery charger, the Type 3-phase full wave bridge. The input of the 480 volts AC 360 hertz at 330. Float output voltage is 72 at 25 degrees Celsius, 67 at 55 degrees Celsius, 88.4 at negative 18 degrees Celsius. High rated voltage points at 79 at 25 degrees Celsius, 74 at 55 degrees Celsius. That is the the amperes or whatever. I don't know. 9 degrees at 18 degrees Celsius. Output current 30 amperes. Current limit 33 amperes. Opening temperature range 18 degrees Celsius to between 55 degrees Celsius. Low voltage power supply. The type of 3-phase transformer rectifier 60 diode bridge is the input of 480 volts of 3-phase 300 volts, input of the 480 volts AC, 3-phase 600 surge at 30, output of within 30 amps, the load of 48 volts of the AC, input 72 volts DC, output current of the 300 ampere nominal 330 ampere nominal 40 ampere maximum, ripple voltage of the 2 volts peak and the peak 30 amps, and the regulation unrelated to control circuit of load shed with the transfer relay circuit of dropout voltage adjustable 40 to 75 volt DC, pickup voltage fixed at 10 volts above the dropout voltage, contactor coil 72 volts DC at 0.56 amps, contacts with 100 amps at 48 volts DC. Timer circuits. The high rate of the delay is 16 seconds. Research of the additional 2.25 hours consistent with the current 330A charging after the high rate of the voltage per point is reached and time out of the failure to the time 9.1 hours. Sleeping car electrical power system. The sleeping car electrical power system is also identical to that of the coach described in paragraph 3.2. Differences in the number of the equipment receiving power. Once again, another sleeping car electrical power distribution. The dining car electrical power system. The dining car electrical power system is almost identical to that of the coach. The differences are food service equipment installed in the diner. There are two AAR 220 volt 3-phase 600 hertz standby receptacles as provided, but the receptacles can be used and apply the power to the refrigerator, freezers, and the perishable as are aboard with the standing car locomotive is not usable, available in undesirable or not available or desirable. Primarily, train power is distributed by the food preservation equipment through the M448 volts to the 208 volts. The transform the food preservation power switching circuit is 220 volts away side of the power that distributed by the food preservation equipment to 220 volts, 208 volts, transform and food preservation power switching circuit. The food service power distribution circuit contains two relays which connect the appropriate power source to the food service preservation equipment while opening the circuit to the other power to the source, preventing the circuit being completed with it to one of the power sources where the other source were connected. For example, when the power supplied with the locomotive, the MC is energized, but the SC is de-energized. The MC contacts the close to the locomotive. The primary power is applied to the food preservation equipment to wayside power. Primary power is applied with the locomotive. Prior power is used in the open of the BMCA auxiliary contacts, preventing the energizing of the SC. Relay. The locomotive primary power that must be removed in the permit the MC de-energizer condition of the MC relay permits the SC to energize, completing the circuit path to the wayside power receptacles. Here is another picture of the dining car electrical power distribution followed by a food preservation power switching circuit schematic, and this is section 4, lighting.